In this video, I'm going to be talking about ions and ionic compounds, and you don't need, for the most part, any prior knowledge about this. So let's get started. So this is an example of a helium atom. It has 2 protons and 2 neutrons and 2 electrons. So this is just an example to show you that all atoms are neutral at first, at least. So electrons are each have a -1 charge, and a proton has a +1 charge, and both of them equal out, and that's why the helium atom is a neutral atom. Electrons follow an electron distribution rule. There can be up to 7 shells or levels where the electrons can orbit the nucleus around. So in the first shell, there can be up to 2 electrons. If that shell gets filled up, the next shell can hold up to 8 electrons. If that shell gets filled up, the third shell can hold up to 18. If that gets filled up, the fourth shell can hold up to 32. And if there are less than 32 electrons on the fourth shell, only 18 go in the fourth shell, and the remainder goes on the 5th shell. And the rule for the 4th shell, which is what I explained before, applies to the rest of the other shells, so the 5th, 6th, and 7th shell. And the outermost shell can never have more than 8 electrons. If an atom has a full outer shell, it doesn't react with anything. So noble gases are the only atoms that have an outer shell, that have a full outer shell, so they don't react with anything. So those include helium, neon, argon, krypton, xenon, and radon. The other elements are jealous of the noble gases, so they make bonds. And today I'm going to be talking about ionic bonds. So ionic bonds happen strictly between a metal and a nonmetal. So during ionic bonding, there happen to be ions happening. That's why it's called ionic bonding. So metals become cations, and those are atoms with a positive charge. Nonmetals become anions, or atoms with a negative charge. So let's take a sodium ion, and it has 1 valence electron, which is basically the electron in the last shell. And what if we remove this electron in the last shell? I'm going to explain why later, but for now, there's 1 less electron, which means there are still the same number of protons, which is 11, but there are only 10 electrons now. So it means it's a cation, or has a positive charge because there are more protons which have a positive charge than electrons which have a negative charge. So now let's take a chlorine atom, and it has 7 electrons in its last shell, or valence electrons. And if we add 1 electron, I'm going to explain why later again. So now it has, again, 17 protons, just as usual, but there are 18 electrons now. So it's an anion because it has more electrons which have a negative charge than protons which have a positive charge. So now let's talk about why the sodium atom gets rid of its valence electron, the 1 valence electron in its 3rd shell. So if it gets rid of it, it now has 8 electrons in its last shell, which is actually the 2nd shell now. So it's happy now, and that's what all atoms want. So now let's do the same to the chlorine atom. So the chlorine atom has 7 valence electrons, and what if we add another valence electron? So if we add another valence electron, it now has a full outer shell of 8. So basically there are 8 valence electrons in its 3rd shell, which means it's happy now because it's full. So now let's put these two together. On the left is a sodium atom with, of course, 1 valence electron, and on the right is a chlorine atom with 7 valence electrons. So let's say the sodium atom donates 1 electron to the chlorine atom, and now the sodium atom becomes a cation, and the chlorine atom becomes an anion. And because opposites attract, there is a positive and a negative, so those two become an ionic bond, and it's called NaCl, or sodium chloride, which is table salt. There's actually another way to draw their ionic bonds, and actually it's called Lewis dot structure. So here, basically a dot represents a valence electron. So sodium has 1 valence electron and chlorine has 7 valence electrons. So you can just draw an arrow pointing that sodium donates an electron to chlorine. So now that you know the basics, I'm going to show a little more complicated example. So for this example, I'm going to be using aluminum and oxygen. And aluminum has 3 valence electrons and oxygen has 6 valence electrons. So we know what we're dealing with. So for this example, I'm actually going to be using the Lewis dot structure to make it a little bit easier and quicker. So I'm going to draw an aluminum dot structure, and it has obviously 3 valence electrons, and I'm going to draw an oxygen Lewis dot structure. And I'm going to show that aluminum is donating 2 electrons to oxygen, which is the maximum number of electrons that it can donate because oxygen can't take any more valence electrons. So now oxygen is happy, but aluminum is not happy because it has still 1 more electron to give. So I'm going to draw another oxygen atom, and aluminum is going to be happy now because it donates all of its 3 electrons. However, oxygen is not happy now, so you can see why this is kind of complicated. So I'm going to draw another aluminum dot structure and another oxygen atom, and as you can see, all of these work out. So the final formula is Al2O3. Thanks for watching. Please like, subscribe, and comment. Bye!